Hello, I hope you can hear me. Hello, I hope you can hear me. Okay, so we are looking at this physics question, practical. These are the set GCE questions. So I'm going to look at electricity today. Maybe another time I'm going to look at other question. Okay, this is how you call it alternative to practicals. That is how it is called. Okay, I hope you have your graph ready. Okay. So look at the question. It said, look at the circuit. This is the circuit diagram. You have a key. You have ammeter. You have voltmeter. Then you have a rheostat. This is okay. So how you are saying it now? Hello?
Yes, sir.
Okay, so we have the key, which is the one labeled key. You have the ammeter, which is what you use to measure current. You have your rheostat, which helps for regulation of current also. Then you have the voltmeter, and then you have your EMF. So if you read the question below, this is how they decide alternative to practical questions. If you are writing GCE. It said an electric circuit is connected in figure 1.3 with the key opened. You can see the key is opened. So when the key is opened, that means there's no current flow into the system. Okay, when the key is open, means no current flow into the system. Then the voltmeter reading E is read and recorded. The key is then closed and the resistor is adjusted until a small current flow in the circuit. The current I, the potential difference V, are measured from the ammeter and voltmeter respectively. So the procedure is repeated 4 more times by adjusting the rheostat each time and obtaining I and V, values of I and V. So look at it, figure 3.1a and 3.1b shows the ammeter, shows the values of I and the corresponding value of V respectively. Where I is 1 to 5. You say read and record the value of E, read and record the value of I, read and record the value of V, and evaluate P equals to E minus V in each case. You see that? Now, if you go to the diagram they will draw for you, this is the diagram where your reading will be obtained from. Are you seeing it? So the first one is this first one is our I, which is our ammeter. Then this is our V, which is our voltmeter. Is that clear? So we have to read the value of I1. Look at here, you have I1, I2, I3, I1, I2, I3, I4, and I5. Here you have V1, V2, V3, V4, and V5. And here you have your EMF, which is your E. Okay? Are you there?
Yes, sir.
Okay. So this is so these are the values. Now remember, I said we should record. Let's go back to what we are asked to record. We have to record what? E, right? So let's get the value of E first. Remember, I taught you how to count graph, right? The other time. Isn't it? Remember I taught you how to count graph. So let's assume we have a situation like this. And assume we have a situation like this. So if here is 0, for instance, and here is let me see, here is 1, no, let's say here is 2, and here is 4. Are you getting it? So it is important for us to know the value of one of the lines, small boxes, right? So I remember, if you remember what we said, I said one box is the difference between these two. The difference is now what? Is 2. How many buses are within this space? Is 5. So 2 over 5 is what? Will give us 0.4. Isn't it? So meaning one bus along this line is 0.4. The same method you will use to count this your ammeter and your voltmeter. Now you need to count each of this line. Here's our 0 now. Here is 0. Each line is now what? So if here is 1, the difference is now what? One line now. One line will be what? I need to know the difference. Difference is now 1. How many lines are there? 10. A line is 0.1 in the ammeter. One line is 0.1 in the ammeter. Are you following? Are you following? Are you following? So one line is 1 in the ammeter. So you are going to do the same thing for the voltmeter by estimating the value of one line in the voltmeter. So here is 1 also. How many lines are there? If you count, it will be 10. So one of the line now will be what? One line in the voltmeter now is also 1 over 10. A line is 0.1 volts. So one line in the voltmeter is also 0.1. So with that in mind, I will count the values for, if you look at our E. Our E here is just 3 precisely. Value of E, now look at line for E, the value is just 3.00 volts. That is value for E. So from there I will read V1, V2, V3, V4 and V5. The same is also true. I will read I1, I2, I3, I4 and I5 for each table. Then what the question demanded, I'm to evaluate P minus E minus V. I have to evaluate E minus V as value of P. So let's put that into account. That will be question 3A, Roman figure 1, 2. Then everything will end up here. Look at this page. So we should tabulate our readings. So I tabulate the reading for I, reading for V, and reading for E, and reading for P, which is E minus V. So that's what I'm going to do here. So what I will do here now, I will draw a table by first of all starting with the serial number. I will have 5 experiments, 1, 2, 3, 4, and 5. So I will have my E in volts. E is 3.0 from what we counted. Look at it here. Our E is 3.0. So here becomes 3.00. Then what is now throughout the experiment is 3.00. That is value of E. It did not change. 3.00 throughout the experiment. That's the value of E. Then from there, I will go back to say what will you ask to record the I. Let's record our I now. I in ampere. That's the current in ampere. So I will start to record each of the current now, starting with I1. You have to be very observant to make sure you are counting from I1. So if a box is one of the lines 0.1, if I count, here is now 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So my I1 is 0.80 to 2 decimal. Then I'll go to I2. This is 1. The box is 1. In one line is 0.1, 1.1. Here's now 1.2. Here becomes 1.20. Then if I count down, so here will give us 1.5. So my I3 is 1.50. Then I4 is 2.0. I4 is now 2.00. And I5 will give us 2.30. That's now my I5. So on that, I also estimate the values of V in volts based on the question requirements. We also have to record V. So my V now is second diagram. From what we calculated, the line is also 0.1. So starting from V5 came first before V1. We have seen V5 before V1, so this counting will start from V5. Counting will start from V5. So here will be a line is 0.1, here is now 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So my V5 is 0.70. From there, I will go to V4. V4 is just pointing directly at 1. We evaluate P equals to E minus V. P equals to E minus V. That is the value of P. So my P, so I will have another column for P equals to E minus V. I also put the unit. EMF is in volts. Potential difference in volts. The unit is also in volts. I always state the units. So what is my P? What is my E now? My first E is 3. My first V is 2.2. All you need to do is to subtract by saying 3 minus 2.2. That is what you should do. 3 minus 2.2. That will give us 0.8. So here it becomes 0.80. Then we have E is 3. Then V is 1.8. You have 3 minus 1.8. So let's so this is the value of the table from what we've gotten, and we move to the graph to plot the graph now of I against P. So the I will be on the vertical axis and the P will be on the horizontal axis. Although they did ask us to start from the origin, but you can decide to label your graph to the origin. So what you do, you have to draw two axes, as said. As we said, you label here as, here is now I in ampere. Then the second side of the graph will be our P in volts. Okay, so we need to take K, which is also allotted in mark. So for me to take K, I'll consider the highest value of I and the lowest value of I. The highest value is 2.3 and the lowest value is 0.8. So I can consider 2 cm to 0.5 units. I can consider 2 cm to 0.5 units in this for the I-axis, 2 cm to 0.5. Then let's look at the P-axis, almost the same value, 0.8, 2.3. I can also consider 2 cm to 0.5 units. Okay, 2 cm to 0.5 units, depends. If you have a larger graph, you can consider 2 cm to 0.2 unit, because the highest value there is just 2.3. So it depends. So what I will do now is to So this is the table of value. I hope you can hear me.
Yes, sir.
Do you know how we? I hope you follow through how we obtain the table of values.
I just joined it.
Okay, you did not follow through. Okay. So this is the what the data given to us. That's the data given to us. Let me erase it and let's start all over. So the way I taught you how to count graph is the same method you will use here. You know, I taught you how to count graph the other time, right? When you have your values like this, when you have values like this, and let's call here 0, let's call here 0, let's call here 2, let's call here 4. So I need to know the value of one line. So for me to know the value of one line, I need to know the difference between here and here. What's the difference now? Difference is 2, right? So how many lines are there within that difference? 1, 2, 3, 4, 5. So 2 over 5. So one of the line now will be what? Will be 0.4. Okay? Will be 0.4. So the same idea you will translate. The same idea you will translate when you are working with current electricity like this. The same value, the same thing you will translate. So what you do now, you can see from here to here is 1. How many lines are there? Let's count. You see you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1. So the difference now is 1. Total line is there, what? Is 10. So a line is 0.1. So you do the same thing here also. They are the same thing. If you count the lines is 10, the difference is 1. A line here is also 0.1. Are you there? So a line is also 0.1. So what I will do now is this. I will now count the value of I1. Look at it. This is I1, I2, I3, I4, and I5. Then this one now started with V5. You have to be very careful. The other one started with 1. This one started with 5. You count you count like this. You are counting like this from the 0. You are counting from the zeros. So this one started with 5. Then 4. Then down to our E. Our E, which is the EMF now, the value is what? From the reading is 3.00 volt. Right? It's 3.00 volt. That's our E now, 3.00 volt. So from there, you're asked to what? Look at what I want to ask us to do. I've asked to record the value of E, which we've done already, 3.00 volts. Right? Then we're asked to record the values of I, values of V, and also evaluate P as E minus V. You see it? P is E minus V. So that is what we did here now. Let's start now counting. So what's the first value of I1 now? Let's count it, starting from 0. Here is now 0.1, 0.2, 0.3, 0.4, 0.5, right? Here will be 0.6, 0.7, 0.8. So my I1 is what? 0.8. So I2 will be what? I will start counting from 1. Here is now 1, 1.1, 1.2. So my I2 is 1.2. Let's go to I3. Here will be 1.3, 1.4, 1.5. I3 is 1.5. I4 is just 2. I5 will be what? 2.1, 2.2, 2.3 for my I5. So if you do that, these are the values we have now. The EMF will be constant throughout the experiment. It's 3, 3, 3, 3, 3, 3. So my I, the first one is 0.8, 1.2, 1.5, 2.0, 2.3. So let's also count V. Let's also count V. Let's see now. A line here in the V, a line is also what? 0.1. Agreed? So my V now will be what? Starting from 0, here will be 0.1, 0.2, 0.3, 0.4, 0.5. That's now 0.6, 0.7. So my V5 is what? 0.7. Look at it here. Because this is number 5 now. So don't come here and write it as number 1. Is the fifth, if the V5 is the 5th number in the reading. So that's why I'm putting there as 0.7. Then from there, we move toward V4. V4 is now what? It's at 1. V4 is now 1.00. All your values must be to 2 decimal. Then V3 is now what? Here is now 1.1, 1.2, 1.3, 1.4, 1.5. V3 will give us 1.5. Then look at V4. Here is now 1.5, 1.6, 1.7, 1. So my V2 now is what? Is 1.8. Then my V1 is now what? Is 2. Here is 2.1, 2.2. So my V1 is 2.2. So the question also was we should evaluate P equals to E minus V. What is my E now? The first E is what? Is 3. My V is what? 2.2. So it's not 3 minus 2.2. That will give us 0.80. Then 3 minus 1.8, that will give us 1.2. 3 minus 1.5, that will give us 1.5. 3 minus 1, that will give us 2. 3 minus 0.7, that will give us 2.3. Is it clear?
Yes, sir.
Then 2, you see we are asked to plot the graph of I on the vertical axis and P on the horizontal axis. So under a real exam condition, what you do now, you open to the graph section. This is the graph section now. Okay? This is the graph section now. So you draw 2 axes. Always don't rule in between. Don't rule in between. Always use the last part of the graph. Also the last part here of the graph. You see that? So I will label here I in ampere with the unit of current. Then I will label the horizontal as P, which is what? What's the unit? In volts. You see that? So then you have to label your graph. I will say I'm going to a graph of I in ampere versus P in what? In volts. You see it? A graph of I in ampere versus P in volts. So you have, before you start calibrating your graph, you have to take the scale of the graph, right? You have to go back now to the I. The highest value of I, consider the highest value, which is 0.8. The lowest value 0.8. The highest value is what? 2.3. Right? So based on this one, what scale can you take? If the lowest value is 0.8 and the highest value is 2.3, what scale can you take on the vertical axis now, which is the I, based on the values that we are having? What scale can you take? I told you to always use 2 centimeters. So 2 centimeters to how many units? Okay, 2 centimeters to how many units? So you can, from based on this, I can use 2 centimeters to 0.2 units. So I will say, I will now write scale. I have to write it as scale on vertical axis. On vertical axis, which is the I in ampere. I will say 2 cm to 0.2 ampere, because it's in ampere. Instead of saying units, you can just use the unit of the current, 2 cm to 0.2 ampere. Now, if you go to the p-axis, now, we should to take scale for it. If you look at the p-axis, the values are similar to the I-axis. They are the same thing. I think that's the same thing. That means we can use the same scale. We can use the same scale. I can also say scale on horizontal axis. So don't go and write x-axis and y-axis. You are not plotting a graph of x against y. So that's why I'm using, instead of writing scale on x-axis, I'm using scale on horizontal because I'm not plotting it against x. Horizontal axis, I will write 2 cm to the same 0.2 volts this time around, because the unit of the horizontal is in voltage, right? So what you do now, based on the graph now, let's just do it here. Let us do this graph now. So I will have here as P in volts. Here is I in ampere. So here is now 0, 0. So I will label the graph 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0, 2.2, 2.2, then 2.4. Right? I'll do the same thing here. 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. So it's assumed that you have to extend. So, but make sure, if you are counting, make sure it will occupy the entire value. So that you have to count first. Don't just calibrate first. Don't calibrate first. I've told you this thing before, right? Count what the value will occupy the hand. So when you say 2.0, this is 2.2, 2.4. So like I told you, don't just start plotting until you calculate the value of a box, right? Remember we said one box is the unit you are using, is the unit over total boxes, right? Total boxes. So what is the unit we are using? We are using 0.2 over what? Over 10, which is for 0.02. A box is 0.02 on both axes, since we are using the same thing on both axes, right? The box is now 0.02 on both axes. So you can start plotting now by coming back to our table. So in the table now, when P is 0. You move from the horizontal to the vertical. When P is 0.8, my I is also what? 0.8, right? So I will come to the graph. Here is 0.8. I will come here 0.8, 0.8. So I need to asterisk this point, right? Then the next one is 1.2, 1.2. So I'll come to 1.2 on the horizontal. This 1.2, I will follow it all till I get to the vertical, also 1.2. I will asterisk that point. The next one is 1.5. So 1.5 now you can see we didn't label anywhere as 1.5. It's now you're now required to count the value of a box. A box is 0.02 based on what we counted, right? So if you count it, you're going to fall in between 14 and 16. You also asterisk. So you continue. Then the next one is what? After 1.5, what do I say next? 2 and 2.3. So 2 versus 2. So at 2, I also come to 2. Then finally, you mark the last one, 2.3 to 2.3. So you mark the last one, 2.3, will be between 2.3 and 2.4. You also mark 2.3. So what you do now, you take your ruler and your pen, and you take a ruler to draw the line of best fit. You see that? Draw the line of best fit. So based on the fact that the two values are the same, you are going to obtain a perfect straight line graph from the origin. Is that clear? Hello? Yes, so after that, you now go to the next question. Well, next question, so we should do. Look at the next question here. Next question say determine the slope x of the graph. Right? So you have to write slope now, open bracket x is equals to change in I, which is the vertical, over change in v, which is the horizontal. Sorry, change in p, not v. Change in p, not v, over change in p. So which is I2 minus I1 over P2 minus P1. You see it? So you now come to your graph to take your slope along any point here. So you can come to your graph like I can take it here and here. Perfect horizontal and perfect vertical. So here I will now write change in I. Then here I will write change in P. Change in P. So you can trace the points down if you want. I can trace this point down if I want. I can trace this point to the vertical. I can also trace this point to the vertical also. I'll trace these 2 points so that I can count precisely which points I'm having. Do you understand? So based on what we've done now, we have 2.3 and 0.8, 2.3 and 0.8 on both sides. So I'm going to have the slope now will give me, let's do it here. My slope now will give me slope x. X will give me 2.3 minus 0.8 over 2.3 minus 0.8. So all you need to do now is to use a calculator to subtract 2.3 minus 0.8. I'm going to have 1.5 over 1.5. What are we having? That will give us 1.0. But you have to put the unit. The numerator is what? Is ampere. Denominator is what? Is volt. Are you saying it? So the unit will be ampere per voltage. You must put the unit, otherwise you're going to lose a mark. So the unit now is 1.0 ampere per voltage. So that is for the slope. So let's go to the next question. VII. So you should state 2 precautions you will take if you have to perform this experiment in the laboratory. Now look at the word if you year 2. So you are not performing in a year 2. That means it's not a laboratory practical. But what precaution will you take if you have to do it in the lab? Number 1, you must ensure tight connection. Ensure tight connection of the circuit. That's one of the precautions. You have to ensure tight connection of the circuit. Then 2, you have to ensure that the key was open when no reading was taken. If you go back, you will see that the key, it was